When about 1 year ago I received the request to become a member of the review panel, it didn't take me very long to understand that this topic is really a hot potato to many stakeholders. You already saw one part, but there is another part including a lot of questions, and that's civil society as a whole. And this was a reason for me to say, yes, I will be part of this critical review panel and to contribute my know-how from the very beginning. What it meant, Professor Azabagic already mentioned it. I think we can stress again, as you heard before, that we didn't take things easily. During this process, we kept changing and adapting basic assumptions for this study so that in the end we see a valid result of the whole process. I do not want to really comment a lot on the review as such. I'd like to mention some things that I consider relevant and important. The crucial thing, as you already heard, is that in the study we have a number of assumptions and definitions which then have an effect on the conclusions and results. In order to make sure that we can work with this and can make a contribution to increase transparency regarding these matters, which are really very important to many people, we wanted to be as transparent as possible in order to avoid any shortening or any unnecessary changes. So I think we should not only focus on the CO2 footprint, but we should also consider the conflicts that we see in the result of the study. A number of items can be mentioned where the assumptions and definitions are relevant. One focal area is that if you look at the future development of the waste sector in Germany, well, we assumed it will be the situation of 2030, and there is some uncertainty involved this, and there is a certain type of half-life included in the results. And of course, there will be new developments, and they should be looked at as well.
And the second point, which is centrally important, is on the objective of the expert opinion, is we looked at the balance sheet and the pyrolysis and also reviewed it and only looked at one possible resource stream, which is processed in the pyrolysis process. Now, we can't cover the entire range of waste products. We can't look at all the different fractions of feedstock which is used. One important point is also that particularly when assessing the quality of the product, the mass balance approach is used. And I believe that it is good that BASF does it transparently and openly, because via a chain of custody, you have a recycled product, but with a low quantity of the material, you don't have so much recycled materials in the end products. And yeah, since there were so many beautiful pictures of marine littering, which could be addressed with the possibilities of chemical recycling, I would also like to mention another point, which was not the point of the study, is that we should remember to avoid plastic. And that is my last point, and I'll hand over to Simon Hann.
Thanks, Florian. First of all, I'd like to commend BASF for their commitment to transparency throughout this process. I can see a genuine desire to conduct this LCA and the process out in the open, as they themselves are keen to understand where pyrolysis might fit in with their business in the future. I think the study genuinely moves understanding forward, and compared with other LCA studies on the subject, it is the most comprehensive to date. In terms of the limitations of the study, I want to reinforce that it does not represent the final word on the subject and should not be used to justify policy decisions where the scenario differs significantly from the German specific case presented here. The local waste system and energy mix will play a large part in how much the results can be applied in other locations. However, the study represents a good step to move the conversation on more generally. I would also like to discuss two other aspects that I think are most influential in the results, which are the quality of the input and the quality of the output materials. The quality of the input material and the subsequent sorting steps have a significant influence on achieving a high yield from the process. The yield is key to the environmental benefit, and the input material is key to the yield. It still remains to be seen whether polymer-to-polymer recycling using pyrolysis can be achieved at commercial scale in practice. It is also important to recognise that the same improved sorting and identification technologies that will be required for mechanical recycling to meet EU targets will also be needed for chemical recycling in order to maximise quality and yield. There's no shortcuts here. Both technologies require high quality inputs to maximise the environmental benefit. This is linked to the energy requirement, which would increase as more pyrolysis soil purification steps are needed. It is important to note that the key purification step in the LCA is based on lab scale data and expert judgment at present. The second aspect is the comparison to mechanical recycling in terms of the output quality. It has long been an issue in LCA around how we deal with the loss of quality in plastic recycling to fairly compare the end-of-life impacts. The automatic assumption that recycled plastic replaces a virgin alternative is no longer acceptable, especially in studies that are designed to influence policymaking. In the BASF study, the circular footprint formula developed for the European Commission is used to convey this by assuming that the market value and thus the environmental benefit from recycling the polymer is half that of virgin plastic. This is a sensible assumption in the context of this study, but it is still an assumption nonetheless. This is very much an assumption that is market-driven and subject to change between countries and over time. It is also linked to the quality that can be achieved from mechanical recycling, which is also likely to change over time as the drive for more recycled content in plastic products increases. What the result of this study shows is that the true cost of producing circular plastics, which has largely been hidden through not putting a true environmental value on low-grade recycling and the exporting of Europe's plastic waste to Asia, where it enters a black hole. To make plastic circular using pyrolysis, it currently requires a high energy input and a large amount of losses compared to the state-of-the-art mechanical recycling. The high losses of around 50%, according to the study, still mean that there would be requirement for a large amount of virgin material replacement to maintain the system. So this technology should not distract from the focus on reducing our need on raw materials. The next step for chemical recycling, bearing in mind that this overarching name refers to many different technologies and providers, should be to look at the environmental impacts from a systems perspective, to determine where and how it might fit in with how compatible it is with the future. This is important as we need to have a vision for the future rather than base decisions on the current broken system. Being locked into a new technology in the same way some countries have with incineration may be problematic. In this regard, I think we need to focus on sustainable consumption rather than continued growth, particularly with single-use products. Thank you.
Thank you, Florian from Öko-Institut, and thank you, Adisa from Ethos Research Institute, for giving us this critical review. Thank you, Adisa, for sharing the critical review. So I do not see any immediate questions on the critical review. Und ich gehe auch zurück ins Deutsche.
And I'll go on in German, because I've seen that there are 700 people in the chat. You're very patient. You listened for a long time. We'll have a short break, and we are exactly on time at 3:10. We are going to continue with the first discussion block. So please use the time to enter your questions in the chat. Christian already received a number of questions. You talked about the mass balance approach before, but there are questions on that too. Now a short break, and see you and hear you again at 3:10.